Okay, so the paper was a 3-hour paper out of 150 marks. Let's see what we can do and how we have done. So 10 questions, all questions were compulsory and all of that. So question number 1, just as usual, they want us to solve for x. So in this case, we have options, but for 1.1.1 it's straightforward. Okay, it's a dot product. So we can just say that 2x is equal to 0, or 3x plus 4 will give us a 0. So in this case, x is going to be a 0, or our x is going to be a negative 4 over 3. Okay, so it could be negative over 3, or someone could say negative 1,333, no problem. Then 1.1.2, the condition, correct to decimals. So whenever we see that condition, what must come into our mind should be the quadratic formula. But before that, let's create the standard equation first. So that's going to be 2x squared minus 4x plus 1 is equal to 0. So our a is a 2, our b is a negative 4, our c is a 1. So if I try to substitute into the quadratic formula, negative b plus minus b squared minus 4ac divided by 2a, that's gonna be a positive 4 plus minus, I know that negative 4 squared is gonna be 16 minus 4 by 1 by that is gonna give me 8 divided by 2 by 2, which is a 4, which is 4 plus minus square root of 8 over 4. So I don't need to go through all of this, just punch that in the calculator. So the answers that I'm ending up with are basically 1,71, or x is being 0,29. All right, then for 1.1.3, it's an inequality. So do the same thing again. Let's open this up. That's gonna be, let me change back to that. So it's gonna be x squared, I'm opening the square bracket, minus 4x plus 4. Then I'm gonna transpose the 1 to that side. So minus 1 is greater or equal to 0. Then what I can do, just simplify that. It's x squared minus 4x plus a 3 is greater or equal to 0. So if I try to simplify that, remember it's x squared minus 4x plus 3 is greater or equal to 0. Is that okay? Is that true? Let me just confirm with what I have this side. Minus 4x plus 3. Okay, so open the two brackets, or you can use your quadratic, but this is direct. I wouldn't really encourage the quadratic that much, so I can just say minus minus. Okay, that's perfect. So which means my critical values are positive 3 and then a positive 1. Okay, but now since our a is greater than 0 and then the inequality symbol is greater, so we can say that x must be less or equal to 1, or x must be greater or equal to 3. I can use this option, or I can draw my parabola or the number line, whichever option you would choose. Okay, then 1.2 are telling us that the equation root of x minus 2 is equal to 4 minus x. Without solving for x, show that the solution lies within this interval. So for the solution to lie within this interval, we just need to focus on the domain. Okay, look at this. Let's say the root, whatever is inside the root sign, this discriminant. For this discriminant to exist, which means that all of it must be greater or equal to 0. In other words, we don't expect a negative answer to be under the root sign. So, which means our x is greater or equal to 2. Same story, if I get the 4 minus x and look at it as greater or equal to 0, okay, the domain of it is going to be all the real numbers for this case, okay. Then if I try to, remember, we're not solving nothing. When you try to divide both sides by the negative, x becomes less or equal to 4. Now, representing this in the inequality format, we can say that 2 is less or equal to x, since x is greater or equal to 2, and then it's less or equal to 4. We are not solving it, we are just representing the domain formats. Then 1.2.2, that's where we need to solve. So since it is a third equation, equation with sides, we just need to square both sides so that we get rid of the root sign. So square that and then square that. The root sign falls away. I'll have x. Let me jot it this side. We had x minus 2 is equal to 4 minus x. Perfect. Okay, we said we're squaring this and then square that. Okay, so it's x minus 2 is equal to, that's going to be 16 minus 8x plus x squared. Let's get a standard equation, and that's going to be x squared minus 9x plus 18. I'm moving everything, is equal to 0. Then I can factor this out. I can use 6, and then I can use 3 minus minus. So which means my solutions are 6 and 3. But then since we're dealing with the third form or third equations, I need to test my answers. Okay, so let me see. If our x is a 6, it's going to be 6 minus 4. No, 6 minus 2 is a 4. Then square root of 4 must give us a 2. Let's see on the right hand side, it's 4 minus 6, which is negative 2. So this is not applicable. Okay, let's try with a 3. So 3 minus 2 is a 1, square root of 1 is 1. And then on the right hand side, 4 minus 3 is a 1. So this stands as the only solution there. Then 1.3, solve x and y simultaneously. 6 marks, so I need quite a lot of space. I'll say 3x, this is 1.3. Okay, so we have 3x plus y is 2. And then the other one is y squared is equal to x squared minus 1. Okay. So I can make y the subject. So it's equation 1. This is equation number 2. Make y the subject. It's going to be 2 minus 3x. Let this be equation star or equation 3, which I must substitute into this equation. So substitute equation star into equation number 2. Okay, so that's going to be 2 minus 3x. Everything must be squared, is equal to x squared minus 1. And I open this square bracket. It's going to be 4 minus, that's going to be 12x plus 9x squared is equal to x squared minus 1. We can use the FOIL. Okay, alternatively, you can apply the FOIL method so that you get that approach correct. Okay, we now create the standard equation. Pull everything to one side. I'm going to pull everything to the left. So I'll have 7x squared minus 12x plus 5 is equal to 0. I can factor this out. Number that I multiply to give me 7x squared is just 7x and x. 5 is a 1 and 5. Should I put it here? Let's see, minus minus, so 7x. Wait, 7x squared minus 7x minus 5. It's perfect. Okay, so if I do that, or you can switch to quadratic, no problem. Which means the 7x minus 5 is a 0, which means x is a 5 over 7, or the x is a 1. Then I just need to get these values and substitute them into equation star. So my y here is going to be 2 minus 3 multiplied by 5 over 7 is 2 minus 15 over 7. I'm going to get negative 1 over 7. Okay. Then this side is going to be y is equal to 2 minus 3 times 1, which is a negative 1. Okay, so I have x as a 1, y as a negative 1. X as a 5 over 7, y as a negative 1 over 7. So those are going to be my solutions. And then 1.4. 1.4. So they're telling us that if r plus s is a and r minus 2s is b, r plus 2s is a, r minus 2s is b. Can we prove that rs is the same as this? So it's going to be tricky for me to just get r and s alone. So instead of starting from the left hand side, I'm going to start from the right hand side just to prove that. Let me just put it even here. So where there is a, I'll replace that. So it's going to be r plus 2s but squared, minus where there is b, I'll put r minus 2s but squared. This must be over 8. When I open this up, I'm going to have r squared plus 4rs plus 4s squared, minus, when I open this up, r squared minus 4rs plus 4s squared. This is over 8. I'll open this bracket with a negative sign, so it's r squared plus 4rs plus 4s squared minus r squared plus 4rs minus 4s squared. Everything is over 8. Then I just need to chop. So this chops with that one. Then this chops with that one, since the signs are opposite. So I have just 4rs and 4rs, which becomes 8rs over 8. And then I have rs. Perfect. So my right hand side delivered the left hand side. So that's how that proof was meant to be. All right, then question number 2 are telling us that given the arithmetic, okay, so we have 85, 82, 79, so it's decreasing by 3 if I'm to look at it. Yes, then they want us to determine the Tn. So we know that with an arithmetic, the general term is given as a plus n minus 1 into d. So our a is 85 plus n minus 1 into the d, which is a negative 3. Okay, when I simplify that, I'm going to have negative 3n plus 3 plus that, so which means it's plus 88. So this is my 2.1.1. And then which term would be the first negative number? So I'll get this negative 3n plus 88. So for a negative number, which means the term must be less than 0. Then I solve for n. So I'll move the 88 that side. So negative 3n is less than negative 88. I'll divide both sides by 3. So since I'm dividing by a negative 3, the sign must change. So which means n has to be 29.33. So the first term that is greater than 29.33 is going to be 30. Okay, so T30 is going to be the first negative number. So you can even substitute the 30 in there, you'll get negative 2. All right, then 2.2. They are telling us that a quadratic sequence with a general term Tn has the following properties. T11 is 190. And then Tn minus 1 is given as this. So this equation is just for the first differences. Okay. But there is a condition. N must start from 2 and above. So when I looked at this question, it made me think, and I'm like, if my Tn is an squared plus a bn plus c. Okay, so if I try to get my T11, it's going to be, okay, we said an squared plus bn plus c. So if I'm looking at T11, which is 190, I'll substitute that, it's going to be 11 squared a plus 11b plus c. So which is going to be 121a plus 11b plus c must give us a 190. Okay, but then if I'm looking at T1, T2, T3, for me to get my first differences here, I must use the 4n minus 3. But I must start with n being equal to 2. So if I replace n with a 2, I'm going to get 4 times 2 is 8 minus 3. That's going to be 5. And then I'm going to have 4 times 3 is 12. 12 minus 3 is 9. So which means the second difference is a 4. So from this we can say 2a is 4, which means a is a 2. And then 3a plus b will give us a 5. But since our a is a 2, that's going to be 3 into 2 plus b is a 5, which means b is a negative 1. But now the trouble is, how do we get c? Now, since we have our a as a 2, we have our b as a negative 1, we can substitute this into this equation and look for c. So it's going to be 121 into 2 plus 11 into negative 1 plus c must give us 119. When I do the substitution, that's going to be 242 minus 11, which is going to be 231. Move it aside. So 190 minus 231, and then my c becomes negative 41. The question is asking for the first term. So we know that the first term is given as a plus b plus c. So I'll get my a, which is a 2, my b, which is a negative 1, and then my c, which is a negative 41. When I simplify that, what do we get? What we get? I'm getting a negative. Oh, alternatively, you can just substitute into the Tn formula since you have your Tn. So it's going to be 2n squared minus n minus 41. Then put a 1 there. You get the minus 40. I don't know. That's what I'm getting anyway. So you'll confirm if there's any errors. Please feel free to slot your comments down there. Okay, then they're telling us that the sum of the first 50 terms of an arithmetic is 1275. They want us to calculate the sum of T25 and T26. So sum of term 25 and term 26. So we know that term 25 is going to be given as a plus 24d. Term number 26 is going to be given as a plus 25d from the general term of an arithmetic from nth term, something like that. This is what I'm getting. So if I try to add these two, I'll have 2a plus a 49d. I'll just keep this aside. Then if I try to go back into the general formula for the sum of an arithmetic, it's n over 2 into 2a plus n minus 1 into d. Okay, so I have my Sn as 1275. This is going to be 50, which is 50 over 2, which is a 25, into 2a plus, what is 50 minus 1? That gives me a 49d. Okay, but now what I can see is that this bracket is the same as this. Okay, so instead of me continuing with the 2a plus 49d, I could replace this and say this is T25 plus T26. It's like what the question is looking for. Okay, so which means T25 plus T26 is going to be 1275 over 25. All right, so when I punch this into my calculator, I'm ending up with a funny answer, which is just 51. So 51 is the sum of those two terms. Okay, so that was question number 2. And that's how the 14 marks were obtained. Question number 3. For which values of x will sigma notation k is equal to 1 up to infinity? So these are converging series. So for which values of x would this thing exist? So under this, we just need to know the first condition of -1 less r less 1. This condition needs to be fulfilled. But we need to determine our r. Okay. So if I replace k with a 1, I'm going to have 4x minus 1. If I replace k with a 2, I'm going to have 4x minus 1 squared. Okay, so which means my common ratio is 4x minus 1. Okay, so replace r with that. So negative 1 is less 4x minus 1 is less 1. Try to solve this. Move that transpose. 0 is less 4x and is less 2. Divide both sides by 4, which means 0 is less x and is less a half. Okay, but now if it's converging, we don't expect n of the terms to be a 0. Should be 0 comma something something and so on and so on. But when you look at this condition, okay, between 0 and then a half, we're seeing that if we replace x with a quarter, this whole thing is going to give us a 0, which won't make sense. So we can just say that x should not be a quarter. There has to be that condition. Okay, then 3.2. The figure below shows a pattern of 5 circles touching externally whose centers lie in the same straight line with a length L. The radii of the circles form a geometric. Okay, so the smallest circle is 3 units and then the largest is, so I'm going to say my T1, which is A, is 3. And then my T5 is going to be 48. They told me it forms a geometric. So the general term is AR n minus 1. Determine the common ratio. So if I substitute, let me use T5. Okay, T5 is going to be AR to the 4. So that is 48 is equal to 3R to the 4. Divide both sides by 3. I will get 16R to the 4 and then I find the fourth root. Okay, so with the fourth root, I have to get a positive or negative 2. But then since the circles are increasing in size, therefore the ratio has to be positive. Okay, then they want us to determine the length or the value of L. So L is more like the total distance. So what I can see is that we're not just focusing on the radii, okay, but we're now looking at the diameters. So if I focus on the first diameter, which is going to be 6, the second diameter is suspected to be a 12, and then the next diameter is supposed to be a 24. Okay, so we're still maintaining the common ratio of a 2. So what is going to happen here is I can just get the sum. If I get the sum of the diameters. So sum of the first 5 terms, it's A into Rn minus 1 over R minus 1. So that n is going to be a 5. So our first radius, our first diameter is a 6. So that's going to be 6 into 2 to the 5 minus 1 over 2 minus 1. That becomes 6 multiplied by 2 to the 5 is 32 minus 1, which is 31. That gives me 186 units. All right, then 3.2.3. The pattern is extended with 5 more circles to make it 10. Calculate in terms of pi. In terms of pi, the total area of the total. Now, the scenario changes the moment they mention area, because we know that area of a circle is given as pi radius squared. Now, instead of us just talking about the radii individually, we are now squaring them. So this squaring will also affect the common ratio, because now the first term is going to be a 9, and then our second was 6, it's going to be a 36, and so on and so forth. So when we divide this, we're going to say we're going to get a common ratio of 4. So still we're going to look at the sum of the first 10 terms. So it's A into R10 minus 1 into 10 minus 1. Let me do the substitution. So our first area is going to be pi with a 9. So it's going to be 9 pi into the R we said is 4 to the 10 minus 1 over 9, because it's 10 minus 1 to 9. So this 9 cancels that. I have 4 to the 10. It's quite a big number. It's quite a big number. It's 10, that and that and that. And then when I subtract 1, I'm getting why? Whoa. Something is amiss here. Why is this a 10? Hello. Thank you. Why is that a 10? It's supposed to be R, which R is a 4 minus 1, which gives me a 3. So that's a 9. Now that's a 3. I'll have a 3 there. Okay. And then 3 multiplied by that whole thing. Okay, multiplied by 3. Okay, then I'm getting 3, 1, 4, 5, 7, 2, 2. And then there's a pi. So my answer must have a pi in between. Alright guys, so that is what was needed of us in this question 3. Then question number 4, they're telling us that the lines y is equal to x plus 1 and y is equal to negative x plus 3 are axes of symmetry of a hyperbola. Can we show that P is that and Q is that? So we know that these axes of symmetry, they will always intersect at the point where their asymptotes do meet. And then they want us to find those asymptotes. So for that case, we just have to solve this simultaneously. So it's going to be x plus 1 must give us negative x plus 3. Move this x that side, so 2x is going to be 2, and then x is going to be a 1. Substitute this into that, y automatically becomes a 2. So this 2 for the y will be the q, so which means q is a 2. Now with the p, it's going to be negative 1 because when we substitute it back into the equation, it becomes automatically a negative. Now 4.2, they want us to determine the x-intercept of G. So I'll start by rewriting that equation. So it's going to be negative 4 over x minus 1 plus 2. Okay. Then for x-intercept, y must be 0. Negative 4 over x minus 1 plus 2. Move it that side. Negative 2. X minus 1 is negative 4. All right. Open this up. We have a negative 2x. Plus 2 is negative 4. Move it that side. Negative 2x is negative 6, which means x is a 3. So x-intercept is going to be 3 and 0. Okay, so that is done. And they want us to sketch this, the answer book. So I'll just use this space whereby I'll have just this as my y. And then I'll have this as my x-axis. The asymptotes we said was x1 and then y2. So I can have this as my y2. And then my x1 can be somewhere here. I apologize. My lines are not that straight. But it's a sketch, ne? Yeah. Okay, so having done that, the intercepts, we said x must pass through 3. So if this is our point of 3, the y-intercept, if x is a 0 here, that's going to be a 4 plus 2, which is a 6. So somewhere there. It's okay, somewhere there. So just sketch and join. So it must move in that direction, and then automatically it's moving in this direction. So the reason as to why I'm choosing these quadrants, because our A is a negative. So which means the graphs must be between quadrant 2 and then quadrant 4. But even the intercepts, in most cases, give you a hint. So that's how the sketch must be. So we mark the shape, the intercepts, and the correct representation of the asymptotes. Okay, then they're asking us for which values of x is g of x greater than 0. Now, for g of x to be greater than 0, where do we find the graph to be above the x-axis? So, at a point of 3, that's where we are seeing the difference, that one graph is going down and the other is going up. Okay, so since we are interested in the graph being above, we can say that x has to be greater than 3. So all the way to the positive infinity, the graph is going to be above the x-axis. And then between -1 and 3, we see the graph below. And then if x is also less than -1, the graph is still above. So just these two conditions are what we needed for question 4.4 for you to get those marks. Then question number 5, it's a parabola with an exponential. But the format that we've been given is the turning point format for the parabola. Okay, so g of x is b to x, where b is the constant, d is the turning point, beautiful. And the point of intersection, b is the y-intercept, and a and c, okay, a and c are the x-intercepts. First question, determine the length of AC. So whenever they ask you for the length, I mean we need that distance. And for us to get that distance, we need to know the coordinates of A, we need to know the coordinates of C. But C and A are x-intercepts. Along the x-intercept, y is a 0. So the only graph that's cutting the A and C is f. So I'm going to have negative into x minus 2 squared plus 9 should be equated to 0. I can move the 9 that side just to make it quick for me. I don't want to open and quadratic and all of that. So divide both sides by the negative. X minus 2 is equal to positive 9. Then I can find the square root. So pay attention to this. When using this method, do not forget that square root must give you two answers, positive and negative. So if I move the 2, it's going to be x is plus minus 3 plus a 2. So which means the first x is a 5 or the other x is a -1. So this means that this a is at a -1, this is at a 5. They want the distance. So these are 5 units, this is 1 unit. So that's going to be 6 units. So you can say 5 minus -1, which still gives you 6 units. So you're going to mark based on that. Then they want the value of b. So for us to get b, we need a point, and that point is d, the turning point. So the coordinates of the turning point from this graph, since this is a negative, is becoming a positive, and then 9, this 9. Those are the points of the turning point. So 5.1.2, I'm going to say that y is b to the x, where there is y, I'll put a 9, and then squared. Find the square root. B must give me plus minus 3, but the shape of the graph is increasing. So therefore, our b needs to be 3. All right, then they want us to determine the values of x for which g of x is greater than 9. So where is g above 9? For which values? So you can see that if x is a 2 here, below the 2, the graph is below 9. And then after the 2, the graph is above 9. So we're going to say that x must be greater or equal to a 2. And then next, write down the equation of h. If h of x is f of x plus 2 minus 9. So if we get f, which is the parabola, and then we shift it 2 units to the left. Remember the turning point here is a 2. So which means the graph is going to be somewhere here. Okay. And then we drop the graph 9 units below. So the graph is going to be turning around here. So automatically, my equation is just going to be negative x squared, since it's still a frowning graph. We can go the manual way and say this is 5 point. We're saying it's 5.1.4. Said f of x plus 2 minus 9. Originally, our f of x was negative into x minus 2 squared plus 9. Let's substitute. Where there is x, let's put that. So it's going to be x minus 2 plus 2 squared minus 9. No, this was a plus 9 from here. And then I subtract the 9. So negative x squared, this cancels that. So this is going to be the h of x. That will be an alternative. I mean, just get this x plus 2. First replace it there. And then this minus 9, you edit that side, or you subtract it that side. Okay, that is done. Then how can the domain of h be restricted so that the inverse is also a function? So whenever we are doing restrictions, we always prefer to use the less or the greater. So that's the only restriction that can be done. Then can we show algebraically that g of x blah 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 can be done, don't you? So we know that g of x is given as 3 to the x. Okay. Now when we see this, there is a shift. So where there is x, I'm going to replace that. So 3 to the x plus a half. When I split this from my laws of exponents, I'll have 3 to the x and 3 to the half. But I know that 3 to the half is the same as root of 3. So it's going to be root of 3 multiplied by 3 to the x. But we know that 3 to the x is the same as g. So therefore, the g of x plus a half is giving me root 3 g of x. That's what the question wanted. Then 5.2, this one, the Makul one. If f of x is x squared plus bx plus c, and then the g of x is mx plus c. If it's given, okay, let's analyze this graph, that the g of f of x times the g of x is less than 0. So which means this can be a plus and a minus, or this can be a minus and a plus. One is below the x, the other is above. Okay, this is possible for values between -6 and -3, or when x is greater than 2. Determine the value of a in quads, in terms of m. Okay, so what I can do, where do I find this scenario? When I look at this, if I'm to divide this section and also divide this section here. Okay. So if I have this on the positive side, which is a 2, because I'm seeing that scenario, f is below, the other one is above. So positive and negative, it's below. The other scenario is here. At this point, this graph starts to go down, the other one is still up. Then at this point, also this graph goes down, the other one is going up. So this is going to be a -3 for me. This is going to be a -6 for me. Literally, this is what I'm seeing. Then I know that m represents the gradient, but both graphs are having the same c-intercept or the y-intercept. So what I'm going to do is that at this point of c, both graphs are going to have the same gradient. So let me get the gradient of the straight line. Okay, so gradient of the line. So I know that this is 0 and c. Then I can use this as -6 and 0. I can just look at the change in y and then the change in x. So that's gonna be change in y over change in x. That's gonna be -c over -6. So which means m is gonna be c over 6 for that case. Remember, change in y is the same as m. Then I can go back to which option? Let me use the f of x. You guys have done calculus at this point, so I'm going to use the calculus format. So I'll find the first derivative of the graph. Okay, so first derivative will give me the gradient function, but before I go there, what I can still do is just compare the C values. So let's see, because I have the intercepts of this parabola. So since I have the intercepts, I can just say a into x minus x1, x minus x2. So which means it's a into x plus a 3 into x minus 2. Let me try to open this up. A into x squared minus 2x plus 3x minus 6. That's a. It's going to be x squared. Why don't I just open it at once, just to save time? Okay, that's going to be ax squared plus ax minus 6a. Okay, now this okay, so then if I look at it this way, this 6a, the negative, is what I'm going to be equating to be my C. Okay, so in other words, but is that going to make sense for me? There are lots of ways of doing this, but I need a quick way. Okay, so I'm saying C is the same as negative 6a. This, I'm representing it as this C here. Then I don't need C because they said they want A in terms of M. Then I'm going to get this C and replace it with that. So M is going to be negative 6a over 6. This cancels that, which means M is negative A. Since I want A is going to be negative M. So I can do it that way. Or I can find the first derivative of that, which is just going to be 2ax plus b, and then I'll equate it to this C over 6 and then work it around using that direction as well. So this is what the question wanted. A is negative M. So regardless of how you approach the question, we should at least end at some position like that. Okay, so that is question number 5. Question 6. Sketch below g of x, which is an exponential, and then another exponential, a log function. So graph f and asymptote of g intersect at this point. Okay. Then they want us to get the coordinates of a. So this is the x-intercept, and y is going to be a 0. So what I would do with this, it's not that automatic, but I would change this. Y is the log I have with x, okay? I'll change from the log form into the exponential form. So the base is the same. I just switch that. Now we're saying y is 0 along the x-axis. So a half to the 0 must give us x. So which means x is a 1. So they want the coordinates, so it's going to be 1 and 0. It's automatic. You could just write 1 and 0 there. Then they want the domain of f. Where is the domain? Domain, those are x values. Ne? So we can see that this f is not going to go through the y-axis. So what I'm going to say is that x must be greater than 0. Then they want us to get the inverse. So with the inverse, what we do, just switch around. So what is x becomes y. And then what is y becomes x. And then let's write this in exponential format. So a half to the x is equal to y. So that is what they want. So y is equal to a half to the exponent of x. Or alternatively, you can just write it as 2 to the negative x. No problem. And they want us to sketch the inverse to indicate one coordinate. They never said we must sketch it together. Ne? No. But I can sketch it down here. It's not a big deal. Let me just put it down. Okay, so this is y, this is x, so the inverse of f. Now, since f was passing through 1 and 0, it's going to pass now through 0 and 1. Okay. The other point on the graph was a half, this point here. So which means the graph is going to cut somewhere. So if I replace half there, it's going to be the log of a half with a half. What y is it going to give me? It's going to give me 1. So which means this is a 1. I can use 1 for x and then a half for y. So 1 for x and then a half for y. So I can already see the direction. Okay, so they want this. You can say 1.5. Or you can choose any other point of your choice. Now I'm choosing that one. All right, then determine the equation of the asymptote of g. We've already calculated the y value, so I'm just going to say y is a 1. And then describe in words how you transform g to f inverse. So where is our g? 2 to the x plus 1. Okay, so we're saying g of x is 2 to the x plus 1. Now, how do we transform it from that to something like 2 to the x? So start by getting rid of the 1. So you're going to shift the graph. Okay, shift the graph 1 unit down. Then the 1 falls away. And then you reflect the graph. And then reflect the graph. Okay, about the y-axis. Reflect the graph about the y-axis, because when you reflect about the y-axis, the sign on the x must change. So even if just tell us shift the graph 1 unit down, reflect the graph about the y-axis, you get your 2 marks for that. That is question number 6. Question number 7, finance. Okay, 7, they're telling us that an investment does earn 7.5% compounded quarterly. Calculate the effective annual interest rate. All right, so with this, we just need to remember our formula. 1 I effective is equal to 1 plus I nominal over n, the exponent of n. Then I effective is going to be 1 plus 7.5% over 4 to the exponent of 4 minus 1. Okay, so when I punch this into my calculator, okay, saying over 4 to the exponent of 4. And then we subtract the 1. Then I multiply it by 100. I'm getting 7.71%. All right, then 7.2, rhino poaching is a serious problem indeed, guys, and has resulted in the black rhino becoming endangered species. Statistics show that they had 60,000 black rhinos in 1970 and only 4.2 remain in 2011. Determine the annual rate. A decrease as a percentage over the 42 years if the rate is a compound decay. So with compound decay, it's more like, I think they just wanted to do away with the reducing balance, but it's just the same formula. So our A is going to be the 42,000 on a 4.2, and then that's going to be the 60,000 into 1 minus the I to the exponent of 42. Let me just go to the side. Okay, so that is 4.2 is equal to 60,000 into 1 minus I to the exponent of 42. So start by dividing both sides by 60,000. Okay, so 4.2 over 60,000 is equal to 1 minus I to the exponent of 42, and then we're going to find the 42nd root. So that cancels that. 1 minus I is giving me 0.88857. I'll move the 1, subtract, I'll get a negative, and then divide both sides by -1, and then multiply by 100. I'm getting 11.14%. Okay, so that is how the 7.2 was going to be done. Then 7.3, talking about Adam, inherits 27,000, which invests into a savings account. Then the interest is calculated at 5.4 compounded monthly for the full period, 3 years after he invested the initial amount. This guy withdraws some money to make a down payment on the car. I get the value of X if the accumulated value after 10 years is that. So this is more like a timeline. So initially you have 27,000, which 27,000 is going to grow. We can say it's going to grow for 10 years. Then at year number 3, there is a certain amount of money that was taken out. So I'll just look at it. This went for 10 years, then this went for 7 years. After 10 years, we had 17,614.76. How much did this person withdraw? Okay, so what I'm going to do, let me just put it aside. Okay, so we say 27,000. There is a certain amount of money after 3 years, and then after 10 years, we have 17,614.76. So I can look at the 27,000. I can look at it for the first 3 years and then the next, but I would prefer to work it out same time. So we said we're using 5.4, we're compounding it monthly, quarterly, it's monthly. So 4, we move. Okay, so 12 to the exponent, I'm gonna say 12 times 10. Then since this was a withdrawal, I'll subtract 1 plus 5.4%. The exponent is going to be 12 times 7. This must give us 17,614.76. Okay. So then if I look for Rx, it's going to be my 27. Let me just punch that. 27,000, 1 plus 5.4% monthly to the exponent of 120. That gives me 46276.09. I'm subtracting the 17,614.76, and then I'm going to divide by just this portion. So that portion alone, let's delete this first. This is going to be 12 times 7. This should be 84. Okay, so this is giving me 1,4581. Okay, so if I do the subtraction on the computation, 0.09 minus 17614.76, I'm dividing it by 1,4581. I'm getting 19656.63. Okay, so this is what I'm ending up with, 19656.63. So according to this format, this is what I'm ending up with, but there could be another format where you get the 27,000. It first grows for the first we said 5.4% for the first 3 years. Okay, and then the answer we get, we subtract the Rx, and then the whole thing now grows. The balance will grow for the remaining 12 by 7. Okay, after that we have the 17614,76. I don't know, let's confirm this and see if we're gonna get the same thing. So 27,000 into 1 plus 5.4% over 12 to the exponent of 12 times 3. I'm getting 31736.69. I'm subtracting Rx. But why can't I just divide both sides with this thing? So 17614,76 over. We said this side 12 to the that is giving me 1,4581. Okay, so if I divide that, I'm getting 12,080, and say 63 is equal to 31736.69 minus Rx, and then just switch around. Okay, that minus that and minus. Then need to subtract those two, which is just more or less the same. I'm getting 19656,064 now. Okay, where did we get that side? We got 63. So more or less the same thing. All right, so that would be that. Okay. And then question number 8. Determine first derivative from first principles. 2 minus 3x squared. Okay, this is 8.1. 2 minus 3x squared. So that is our f of x. We need to determine our f of x plus h, which is going to be 2 minus 3 into x plus h squared. Go down and tell us the limit as h tends to 0. This is the formula, minus f of x over h. Limit as h tends to 0. I'm going to have 2 minus 3 into x plus h squared minus 2. Then I simplify this. Limit as h tends to 0 is 2 minus 3, that's x squared, plus 2xh plus h squared minus 2 plus 3x squared over h. Limit as h tends to 0 is going to be 2 minus 3x squared minus 6xh minus 3h squared minus 2 plus 3x squared over h. Then I just need to cancel what might seem to be common on top. So these 2 cancels that 2. Then having this as 3x squared. Okay. So the 3x squared cancels the 3x squared. This is what I'm left with. So limit, I need to factorize now. As h tends to 0, I'll have h into negative 6x minus 3. Okay, so we're saying minus 3h. Everything's over h. So this cancels that. Next step is substitution. So negative 6x minus 3 into 0. And then our final answer becomes negative 6x. So if I'm to use the rules, I believe that's what I get. Negative 6x. All right, then 8.2.1. They want us to find the first derivative of this. So this has x, this has x, this has nothing like x. So I'm going to treat this as a constant, which must fall away. So f prime of x is going to be 8x cubed minus 3. Then 8.2.2, I need to split up. So this is going to be 2x squared minus x to the negative a half. This is just the original expression, just writing it in a different way. Then my dx, okay, so the first derivative is going to be 4x plus x to to the negative 3 over 2, because I need to subtract 1. With negative and negative, we get a positive. So that is that. Then 8.3, the following information is given for a function f. Okay, f of 4 is 5, which means 4 and 5 are a set of coordinates. Okay, when x is 4, y is 5. Then they go on to tell us, this is a half, guys, no? Because it's a negative, a half times a negative, you get positive a half, x to the negative. Okay, they go on to tell us that the first derivative at 0.4 is 7. So which means the gradient at 4 is 7. So m is a 7. Now they want us to get the equation of the line. So we know that y is equal to m of x, mx plus c. So that is 5 is equal to 7 into 4 plus c. 5 is 28 plus c. Okay, we move the 28 that side. What is 5 minus 28? I'm getting negative 23. Okay, so c is negative 23. So which means the equation in this case is going to be 7x minus 23. All right, so guys, that is question number 8. Let me just fix this. It's a half, guys. No? Then question number 9. Okay, the function f of x, 2x cubed plus px squared plus qx plus 3 is drawn below. N is 2 and negative 9. M are turning points of f. G is the y-intercept. A, B, and C are x-intercepts, and so on and so forth. Can we show that P is negative 5 and Q is negative 4? So what I see is that I have a turning point. And at the turning point, the first derivative will always be a 0. In other words, the gradient has to be a 0. So I can start by substituting these coordinates first and say, what is my f of 2? So f of 2 must give me a 9. Okay, substitute there. It's going to be 2 into 2 cubed, which is a 16, plus 2 squared is 4, so that's a 4p, plus 2 cubed, plus a 3, must give us a 9. I know that 16 plus, no, it's a negative 9. Okay, 16 plus 3 is 19, so 4p plus 2q, I need to move it that side, it's going to give me negative 28. Let me take that to be my first equation. Then let me get the first derivative. Okay, f prime of x is going to be 6x squared plus 2px plus just a q. Okay, then I must equate this to a 0 because I know that this is the gradient function. Now if my x is a 2, that's going to be 6 times 2 squared, which is a 24. Okay, plus 2 by 2, 4p plus q must give us a 0. I can make q the subject, which is going to be negative 24 minus a 4p. So I need to solve this and this simultaneously. So substitute, replace. So that will be a 4p plus 2 into negative 24 minus 4p is equal to negative 28. So 4p minus 48 minus 8p is equal to negative 28. This and this, I'm getting negative 4p, 48. Okay, minus 28, I'm getting a negative 20. It's a positive 20. Then I'll divide both sides by 4, negative 4. So which means p is a negative 5. Then for me to get q, I'll substitute. So negative 24. Okay, so that's going to be negative 24 minus 4 times negative 5. And then our q becomes a negative 4. All right, then determine the coordinates of G, the y-intercept. That is straightforward. Y-intercept, x has to be a 0 everywhere. We shall be left with just that 3. So it's going to be 0, and 3. And then if it's given that C is having coordinates of 3, in other words, this is a 3, can we calculate the distance between A and B? They indirectly want us to determine the intercepts. Okay, so what I'm going to do, I'm just gonna substitute the p's and the q's. So it's gonna be 2x cubed minus, we said it's 5x squared, minus 4x plus a 3. P and the q will both minus. Okay. So 2x cubed, let me do it this side. 2x cubed minus 5x squared minus 4x plus a 3. That is our cubic function. Okay, so they told us x is a 3 is just one of the roots. I can use my synthetic approach. Okay, the coefficients will be 2, -5, -4, and a 3. And I'm going to take x to be a 3. Remember, this has to be shaded off. This will be a 2. Then 2 times 3, that's going to be a 6. 6 and that, it's a 1. 1 times that is a 3. When I add, I get -1. -1 times 3 is going to be a -3. I get a 0. And then I will draw my diagonals. So this, and then that. So which means I have I'll have 2x squared plus x minus 1 as my new quadratic, which I need to solve. Or you can use the long division. You still end up with the same thing. So it's going to be 2x and x, 1 and 1. I can make this a plus and a minus. So that x is a half positive, or x is -1. Now the question is asking for the distance. So if this is -1 and this is a half, the distance in between, this is going to be 1 unit. This is going to be a half. So 1 plus a half is going to be 3/2 units, or 1,5 units. So 1,5 units, or it can be 3/2. So that is what they wanted us to do. Get the x-intercept and then move on. And then they want us to get the x-coordinate of the turning point of M. So for turning point, just get the first derivative. Okay, so f prime of x. Remember, it was 2x cubed. So that's going to give us 6x squared. Minus 2 by 5, that's going to be a 10x. Okay, and then lastly, minus a 4. This must be a 0. Divide through by 2, I have 3x squared minus 5x minus 2. I can factor this out, 3x and x. I can have a 2 there and a 1. Make this a minus and a plus. Let's see. Does it give us the same thing? Most probably. So x is -1/3, or x is going to be a 2. Now, since m is on the left-hand side, we already have this as a 2, which confirms our answer. So which means m, or the x value of m, is -1/3. Okay, then determine the x-coordinate of h, point of inflection. So with the point of inflection, we need to find the second derivative. Okay, so our second derivative. Remember, the first derivative was x squared minus 10x. Is it minus 4? Yes. So second derivative is just going to be 12x minus 10. You can equate this to 0. So that 12x is a 10. And then x becomes 5/6. So this point here, the x is a 5/6. Okay. Then for which values of x will f be concave up? So for it to be concave up, the graph must be greater than 5/6. And then for which values? is f of x and f prime of x less than 0. So f prime of x is the gradient function, but it's also a parabola, whereby this turning point here, the negative a third, and then this point here, the 2, are the points where the graph is going to be cutting the x. Then this point of inflection must be our turning point for this parabola, something like that. Okay. Now the question is asking us, where do we find f of x, f prime of x, to be less than 0? So one must be below the x-axis and the other is above, or the other must be below and then other above. So the conditions that I'm seeing, or the situations that are available for this kind of scenario, I can see from this point the graph is below and then this one is above. And then for this scenario here, also between 2 and 3, we can see that this one is above, this one is below. So what I'm going to do with those conditions is that x has to be on this side, less than that, and then the x must also be within this region. Which region? From this line here, where the graph starts going up. So that region as well. So my answers are going to be x must be less than negative a third, or the 5/6, because we're using we need the 5/6 here. Because we're talking about the parabola itself. So I'm going to use this 2, not 5/6, 2 and 3. Between 2 and 3. Not 5/6. So it's 2 less x and then less 3. So that's what we had to do. Number 10, last question with probability, are telling us that events S and T are independent. So we know that with independent events, the product of the events must give us the intersection. They want us to get T. So we know that PS and T must be the same as PS multiplied by PT. For us to get PT, do we know the PS? We don't know. We also need to get the PS also. Okay, PS is going to be 1 minus probability of not S. So what is 1 minus 3/4? That gives us a quarter. Then to get PT alone, it's going to be 1/6 divided by P of S, which is a quarter. That's going to be 4/6, which is 2/3. Okay, then they want us to get the probability of P of S or T, so that's going to be probability of S plus probability of T minus the probability of S and T. So S we got as a quarter plus T that we got as 2/3 minus the intersection, which is 1/6. Just punch this into the calculator. I'm getting 9/12, which is 3/4. Okay, and then 10.2, telling me that a group of 200 tourists visited the same restaurant on 2 consecutive evenings. On both occasions, tourists could choose beef or chicken for the meals. The manager observed that 35% of the tourists chose beef on the first evening, and then 70% chose chicken. Can we draw a tree diagram? All right, so this is straightforward. So this is going to be our first evening. We choose beef, we choose chicken. Then on the second evening, okay, then we have beef or chicken for the second evening, beef or chicken. Now we just have to indicate our probabilities. So they told us 35% chose beef on the first. So this is going to be 35%, or you can just write it as 0.35. And then this is going to be 0.65, so that the branch gives us a 1. Second evening, people got 70% for chicken. So this is going to be 0.7, 0.7, which means this is going to be 0.3 and 0.3. So whenever you draw the diagram, they told us you must show the probabilities, which we've done, together with the possible outcomes. So someone can choose beef and beef, beef and chicken, chicken and beef, chicken and chicken. 10.2.2, calculate the number of tourists who chose the same meal on both evenings. So with this, the scenario can be both beef or both chicken. So we're going to say probability of B and B or probability of C and C. So this is going to be 0.35 multiplied by 0.3 plus 0.65 multiplied by 0.7. So let's start by getting the probabilities. 0.35 times 0.3, saying 0.65 times 0.7. That gives me 0.56. Okay, as the probability. Now for me to get the number of tourists, or the number of people that chose the same meal, is going to be the 0.56 multiplied by 200. Okay, that gives me 112 people. So guys, that is that, and that was the paper. It was a fair one, and I wish you all the best in your paper too. Let's meet then.